Question number 7 of the PhilNITS FE afternoon portion of the exam. In this question, we are going to answer sub-question number 1. And just a reminder, we are working on a heap data structure. And also just to remind us that a heap is supposed to be something like this in the diagram. And it says here that a heap should satisfy the following condition in addition to what has been said previously, where any parent node in a complete binary tree has a greater value than or equal to both of its child nodes. That means that if the child node is 5 and another child node is 9, then the parent should be more than the value of either of the children. So that's why we get 10 here and 5 below it and 9 below it. Okay, same goes with the other parts of the binary tree. Like for example, 10 and 8, and the one on top, the parent would be 15. Okay, so I had to emphasize that because when I was doing this question, I was also attempting to understand what was happening. And then actually, what happened was I had to look into the code. And while I was looking at the code, I needed to know more about what's going on. We do have a function named heap up, and that's really what I was supposed to be answering, letter B and C inside the heap up. But then I had to figure out what is the part of the code that is using the heap up, the function. Because we have the function here and the details are here, but I needed to know which part in the code was calling the function. Okay, and then that's where I got into this part where you got the rank by score function. Also, I remember that there are questions where you would be better off answering the succeeding ones first before going to the the question that you were initially attempting to answer, because the um, next parts of the, for example, the code, letter G, should at least help you figure out what would be the answer to those initial questions. Okay, so in this case, in rank by score, the function rank by score, we have here another set of instructions where we see that the heap up is called in this portion of the code. And then we have to also remember that what we're doing is sorting the scores. And currently the scores are not sorted. Now, the next thing I wanted to know is, can we have sample data of the input? Because we have here data and we have here data. And so I had to look into which part of the code is calling this one next, rank by score. And turns out that it's in the main portion of the code where you got here the initial values for the data and then a rank by score function. So that's how I ended up attempting to figure out what would be the right answer for letter G, which is supposedly not yet the initial questions that I was aiming to answer, because I was going for B and C. But then I think that in this case too, might as well answer this part before before those initial questions. And that's why I then looked into the answer group for G. And we have here several. And I did end up choosing letter A, which says size of the data, and it turns out to be the incorrect answer. I think it was also because when we think about size, I was under the impression that it should give us the number of items, the number of elements in the data, and I didn't want to delve too much in this part of the uh, code where you have to divide it by size of something or multiply it and or add something. It seemed to me a little bit too much. But I did also wonder, and eventually I didn't want to use too much of my time, and so I chose A, but turns out that the correct answer is D, and I had to figure out what went wrong. Now it turns out because we're really talking about size of in the C++ computer language and not in Java, there's a difference definitely between having an off right after size. And I think in Java, if you're not going to use the size keyword, it's likely going to be a length keyword. There's the length keyword to figure out the number of elements in an array. In this case, this is also an array, but an array which uses a data underscore t structure, because we can come up with something like that, definitely. And then if we try it out in actual code, what I got, if I chose A as the correct answer, which I did, is 80. And we know that it should be only 1, 2, 3, 4, 5. And so if we add 5 plus this one, 6, 7, 8, 9, 10, there should have been only 10. Now it turns out that uh, it's giving off 80 as the answer, which is incorrect. And so the correct answer should be 10. And it turns out that the size of data divided by size of data underscore t is the correct answer. Now we need to know why it's the correct answer. And it turns out that if we just put the size of data without having the divide portion and get 80, that means that we are only looking for the size of the type that we're using. Now remember, we are talking about this data structure that we came up with, where you got an integer type and another integer type inside it. And that's what we call the data underscore t. And also, by the way, we do have a description in the question about what size of is supposed to mean. And I think these are hints for us to remember to what we are looking for when we're talking about size of, except that sometimes because the description is pretty long and you got so many of these figures and diagrams there, it can be a little bit time consuming, and I think that's why the exam for the afternoon gives you a lot more time to review and also go through the description part. But I think sometimes if you take too long, you realize that it would have been better if you answered the first choice that you got. But again, there are other times when it would have been better if you reviewed. So I guess in this case, what I did was to really not delve too much into thinking and thinking and thinking, and chose one of the answers there, which turned out to be wrong. And I think that maybe particularly for the afternoon portion of the exam, it's better to also look at the other choices and see what's going on there. How come they have divide and multiply there, and maybe there's also a reason why those are there. Okay. And in this case, because we are talking about an int or an integer type, which usually has 4 bytes, and we have 2, I was thinking that that's why it's giving us 8 for the total byte per element, like this. And because we have 10 of those, we will multiply 10 with 8. That's why we get 80 as the answer. Now that's also why we have to divide the value 80, this part, with the size of the data t, which, because we got two integers here, would give us 4 times 2 for the total bytes, which is 8, and that's why 80 divided by 8 gives us the correct answer, which is 10. And I just like to highlight too that we can use our Sanko, our reference, to understand this some more. And in my case, I use the W3 schools to help me remember about these things. And so again, the correct answer for letter G is letter D instead of letter A.